Hi everyone. My name is Moshe Shadmon, and I'm the founder and CEO of a company called AnyLog. I'll talk about a project which is called EdgeLake, which is under the Linux Foundation, under LF-Edge. It's a project which represents an open source version of what we're building at AnyLog. Um, it's a data platform we allow to manage data at the edge outside the cloud. And I'll talk about two topics here. One, I'll go over quickly and give an overview of EdgeLake, what it does, and what is the value proposition here. And the second, I'll talk about federated learning. So federated learning is a way to manage, to create model and run inference such that everybody keeps the data private. The data is not shared in order to create the models. It is maintained, fully owned by whoever owns the data. And so I'll show why EdgeLake is a great fit to enable federated learning. But before I do that, I'll start and talk about EdgeLake, what EdgeLake is about, and how data is managed using EdgeLake. And I'll start by saying that today, companies move their edge data to the cloud, not because the cloud is such a great solution for edge data. I mean, everybody understands that if data is in point A and we need to move it to point B, to the cloud, this is a problem. Companies do it because they don't have a choice. Managing the data where it's being generated at the edge is much more complicated and expensive. That's the problem, the big problem that we solve. So very quickly, how companies work today. So you've got all those things that generate data, whether it's an oil rig or a charging station or a robot, whatever the use case is, the data from the sensors, sometimes through PLCs, sometimes directly, is captured at some edge nodes. And from there, the data, those could be switches, gateways, small servers, and from there, the data starts to travel to the cloud. In the cloud, it needs to be hosted in databases, and only then it can service the application. So for sure, this is not a real-time environment. We're talking about a lot of data, and there are lots and lots of problems managing the data this way. So at the edge, if you look at what companies are deploying at the edge, it's always proprietary software or those old legacy systems like the Schneider's Pi system and so on. There are no data services at the edge. I mean, if you need to solve a problem, you're pretty much on your own. You have to figure out what to do there. And so if you look at the edges, you'll see a lot of proprietary software, or on the other hand, some legacy systems. Then we understand moving huge volumes of data to the cloud is problematic, and all the costs of managing data under the cloud is very, very expensive. And as we said, only then data could be serviced to the applications. So these are the type of problems that EdgeLake is able to address. And the way that it does it is shown by this diagram. So the starting point is exactly the same things, generate data captured at the edge, but this time, AnyLog or EdgeLake. So if you see AnyLog or EdgeLake, it's the same product in that context. It's EdgeLake it's EdgeLake that is deployed there. And what happens here, it generates a virtual layer that spans across the entire edge that lets you see all the data as if it is centralized. So the same application that traditionally had to go to the cloud in order to be satisfied can now go to this virtual layer and be satisfied from there. And this approach is much more real-time. There are no cloud costs. It's all automated. It's all built on plug-and-play components and so on. So that is the basics of EdgeLake. It delivers real-time insight from the data, but the data remains in place. So I'll show you very quickly a short demo for that, and then we'll start to talk about federated learning. So I'm switching to here, to this, you see the map here on the screen?
Yes,
Okay,
with the
great.
map, also.
Yeah. So these are EdgeLake nodes that are deployed all over the world. So if you see a point somewhere, a green circle somewhere, it is really deployed there. And data comes to those nodes from sensors and PLCs and so on, remains in place. And then think about a virtual layer that spans across the entire world in this case, where the data is available. There is no cloud in this model. You could just query it from this virtual layer. And to show you how it looks like from a customer point of view, we'll get back to this map in a minute, but to show you a customer, we brought a very, I think, cool use case of a very interesting customer that is using us. That's a city in Kansas. The city is called Sabetha, and Sabetha has a lot of infrastructure. They have a water plant, wastewater plant. They have electricity that generates the data. So you could see here, those are the generators. So the city has a lot of generators here. So I can select the generator and represent the data that is coming from the generator. This is done in real time. So is the from the wastewater plant, and the water plant. You could see the water level and whatever else they're monitoring. Those are just some examples of the dashboards. This is all coming from this virtual layer that spans across the entire city. And there is no cloud. I mean, 2 weeks after the system went to production, the city asked the system integrator that deployed it to terminate their cloud costs. And I'll show you one more thing, and then we'll start to talk about federated learning, which is how it works under the hoods. So this is a REST API. Everything that I do here, you could do using Postman. And I've randomly selected a node in the network, which is listed here. This is one of the nodes from here. It doesn't matter which nodes, it's completely decentralized. And then the buttons here are pre-configured with queries, so I don't need to type a query. So let's say I want to see the electricity usage in San Francisco in the last 2 hours. So I put the query here, select randomly a node from the network that serves as a gateway to the network. When I hit send, the query goes out and the data comes back as if I'm working against a centralized database. But there is no centralized database. The data came from the edge, from the nodes, which are in this case distributed all over the world. And if I scroll all over to the bottom, you could see the data came back from 7 nodes. So I issued the query to the node in the top. This node saw the query, wanted what we want, and looked at a shared metadata layer that is hosted on a blockchain, which is, again, a long discussion. But the merger of those two things was able to tell the query process which are the nodes that have the relevant data, which were 7 nodes in this case. And then it worked like MapReduce. The query went to those nodes. Each one of those nodes has EdgeLake instance there. Those are the nodes, some of the nodes that are you saw on the map, and each one of those nodes returned a result which was aggregated upstream to my browser. That's how the Grafana dashboards operate and how users interact with the data, whereas data remains in place, managed in an automated way, and you could interact with it as if the data is centralized. So that's an overview on EdgeLake. And let's talk now about on federated learning, how this setup can enable federated learning. So let me go back to my deck. All right, so going back to the deck, so just to summarize, those are all the advantages that EdgeLake delivers. Data stays local. It's all plug and play, by the way. The demo that I showed you was done just plugging software components and configuring them, no engineering work, and so on. This thing has this approach have a lot of implications in the context of AI and especially in AI at the edge. So let me talk, and there are lots of topics that we could discuss. Agentic AI is one of them, but let's focus on federated learning. And I'll start using this diagram. So this diagram is not our diagram, it's coming from Intel. So you could look at the diagram, the link is here at the bottom. And what it shows here on the left side, centralized learning. So it talks about a use case of hospitals. Each hospital has data, and we want to create a model. So in order to create the model, you need to bring all the data to a single place so that you could run the training on it, and only then you can create the model. But obviously, there are many cases because of privacy issues. Hospitals is a great example, but banking, I mean, lots of cases where centralizing the data because of privacy issues is not doable. So how can we do the training? So federated learning is addressing this thing where it says, well, instead of bringing all the data to a single point, let's do it differently. Let's ask each hospital, in this case, do the training on the data that he hosts, and then each one would create a submodel, and then let's just centralize the submodels. Let's just bring the models to a centralized location, and all the submodels would be combined and we'll end up with a unified model that represents all the data in all the hospitals. So that sounds great, but there is a question that is easy to say, well, why hasn't been adopted this approach? And the answer, it's really, really hard to do it. On paper, it looks great. But if you think about it, first, the data is distributed. It's, in this case, in 3 hospitals. By the way, it could be in 3,000 hospitals. And there is no efficient way to operate on distributed data. Nobody also promises us that the data on each hospital is unified. On the contrary, it's probably not. Then there is an issue, a big issue of orchestration. I mean, think about 2 parties that needs to synchronize stuff between them and replace messages, do this, do A, do B, but maybe it's doable, maybe 3 is doable, but if you're scaling this number to many participants, it's not practical. And then you need a lot of knowledge to do something like that. You need to understand distributed systems and databases and networking and cryptography and machine learning. I mean, a hospital for sure don't have those types of expertise. So, and then, all the operational complexity of managing distributed infrastructure and models, and you need to bring it together. So on paper, it looks great. Practically, I mean, companies are not able to do it. And so that's with our model, with EdgeLake, it becomes much, much simpler. Actually, we have a demo, and we don't have time today to show you the entire demo. If somebody is interested, we could share the link. It's on you could get to it from the EdgeLake page under the Linux Foundation, or you could reach out to us. We'll give you the link of the complete demo. So I'll show you, just explain what it does and show you a little bit of the end result of the demo, or the outcome of the federated learning. But just to explain how it works, this is the process. So EdgeLake, like I showed you, is a collection of decentralized nodes that operate in a unified way. And there is the blockchain, which I mentioned in the first part of the discussion, is a place that behaves as an index over the data. It could tell the query process where the relevant data resides, and we're using the blockchain for many, many other things. So in the case of the federated learning, it's a place that holds information that could be shared with many other participants, which is actually something really important, where we say, well, you don't need to synchronize between nodes. You publish your state to a single place, which is the blockchain. And then from there, everybody could know what is going on. So all the synchronization between nodes becomes redundant. So if we take a node and tell it, okay, you'll be the aggregator, you'll be responsible to bring all those models together and orchestrate the process for us. The process could be completely automated. The only thing that users needs to do is to build a training application. And if you have the training application, you ask the EdgeLake node that you identified as aggregator to publish it. Then the next step is you've got all the hospitals in the hospital case. We call it an EdgeLake agent. Each one has a local data that he maintains. And obviously, he keeps it very private and very secure. He's not able to share it. What he would do, and again, it's all automated, he would pull the training application through the blockchain and run the training application. And we could have as many agents or as many hospitals that we want to do it. They don't wait to each other. If they want to participate, they look at the blockchain, pull the training application, and they can do the training. Then when they've done the training, they could just publish the models or actually the submodels. Remember, each model is on the subset of the data. Each model represents one hospital in the hospital example. So each one of those agents publish a model based on the data that he's got, again, to the blockchain. So if somebody decides to drop and is not participating, it's not a problem. All the information that is needed and is available is being reached through this shared metadata layer. And then once it's here, then it would be picked by the aggregator. The aggregator can create a unified and complete model, and then he publishes the final model here. And then once the final model is here, whoever wants to pick it up can pick it up, run the inference using the model, and then he would have the output. So I will demo the output here. So we've done that, and we did a demo, which I could share with you the link to of all this process completely automated. Right now, I'll just share you the end result of that. So let me share again my my screen. So do you see this Postman? So I assume if there is a problem, let me know. So I assume you could see the Postman dashboard. And what?
Yes.
Yeah, oh, great. And what I'll do, so you see here, edge node 1, 2, and 3, edge node 1, 2, 3. So there are calls that would be issued. So we've got 3 nodes participating here. And so, for example, if I send to node 2 this call, what I get back is node 1. What I get back is that you could see this is the test data. So we trained on 80% of the data, and we use 20% of the data to validate, to understand what is the accuracy here. So we could see this is 92, it stands on 92%. And right now, as we speak, those nodes continuously, we have 3 nodes in the demo that are continuously getting data. So the accuracy should be better every round. Those rounds are completely automated using the cycle that I explained. And I could ask them to do inference. So for example, let's go to node 3 now, and I'll ask them to do prediction. And they basically predict. I didn't talk about this use case. This is a live real system. So the demo is not live. The demo copies a live system that does that works in Europe, that is controlling a heating systems in schools and hospitals. And it's trying to predict the temperature to optimize the energy usage. So I've sent to node 3, ask them to do a prediction, and they're telling me that in half an hour, the temperature would be 16 degrees Celsius. So we've got this whole system. It continuously does the create models and makes the predictions better and better. This is live data, and the end result of the process that I mentioned is nodes that are able to do the predictions based on sensor data that comes from the heating system. I'll go back to the demo and show you a little bit more details here. So the story, I should have said the story first, but the story is it's hospital and schools with multiple units, each equipped with sensors to monitor the temperature and air quality. So we've got 4 nodes in this demo. We showed 4 nodes architecture, and 3 nodes stored the data locally. Those were nodes 1, 2, 3 that I showed. And 1 node functioned as the aggregator, like the one that I showed in the diagram. Each unit maintains its own data. So in federated learning, obviously, privacy is the key. By the way, in this case, it's not so much the privacy, like the avoiding centralizing the data. Before using us, they had to take all the data from all those hospitals and classrooms and centralize it, which created a lot of cost and a lot of traffic, whereas here, the data remains local, anything doesn't move, and creating the models is done in a completely automated way, in a much simpler way, much more cost-effective way. So the goal of what I showed you is to predict temperature. We had EdgeLake nodes. The source data was actuator state, CO2 level, event count, humidity, switch status, and obviously temperature. And you could see here the LSTM model. And this was real data provided by an integrator that is using EdgeLake to support this process. So just to summarize what I tried to show you on the federated learning side. So it's a fully automated, federated learning is completely automated, and all those problems that I pointed before are addressed using EdgeLake as the infrastructure underneath the models. AI model enablement, it's automatic model deployments. You don't need to log in to many nodes, push the models there, execute the models. It's all being taken care as a functionality, built-in functionality in the platform. So obviously you maintain the security and privacy of the data. It scales almost without limits. I mean, you could add another node and another node. It's carefully architected such that there is no dependency between the nodes, and it's really simple to deploy and manage. That's it. If you have any questions, we'll be happy to take it.